Welcome back to Systems and Stories. I am Sanal. Let me start with a simple question today. How is your AI assisted development journey going? Have you jumped in completely? Are you in the this is incredible, I can't imagine working without it camp? Or you are still watching from the sidelines, waiting for it to mature before taking it seriously? Maybe you tried it and walked away thinking it slows me down more than it helps. Or maybe you are refreshing release notes every few weeks, excited about the next improvement. Are you looking at AI as the next major shift in software development? Or does it feel like another industry wave that will eventually settle into something ordinary? What fascinates me though is not which side people are on, it's who tend to be skeptical. Because the strongest hesitation I see around AI tools isn't coming from beginners, it's coming from experienced engineers, architects, people who have built systems that live longer than their original requirements. And honestly, that skepticism makes sense. So, why experienced engineers are skeptical? When you have shipped enough systems, something changes in how you approach problems. You develop an internal radar. You can often tell when something looks right, but it isn't. You know that a small shortcut today can become a production incident 6 months later. You have seen abstractions leak. You have seen elegant designs collapse under real traffic. So, when an AI tool produces something that appears confident but subtly ignores constraints, the reaction is predictable. I'll just write it myself. Not because writing code is difficult, but because reviewing and correcting poorly aligned output can be mentally exhausting. At that point, the tool stops feeling like a leverage. It feels like noise. And dismissing that experience as fear of change misses the point entirely. A lot of people describe AI tools as junior engineers, but I think that analogy is misleading. Junior engineers usually lack exposure. They haven't seen enough systems yet. AI tools have a opposite problem. They have seen almost everything, but they don't know why your system exists the way it does. They don't understand which trade offs were intentional, which constraints are crucial or critical, which decisions were shaped by painful past failures. Unless that intent is made explicit, the output will drift. Not because the tool is weak, but because the direction was never clearly expressed. So, when does AI feel slower than coding? Many experienced engineers have had the same experience. You asked AI to generate something, you review it, you fix it, you regenerate it, you fix it again, and 20 minutes later, you realize you could have written this thing in 5 minutes. That frustration is real. But something interesting is happening in those situations. The AI is usually being introduced after the thinking is already finished. The engineer already knows the design, already knows the constraints, already knows the solution, and at that point, the task is execution. And execution without context is exactly where AI struggles. The interesting shift happens when AI is used earlier in thinking process. Instead of asking, write this function, try asking, what are three possible ways to design this? What assumptions does this architecture rely on? What might fail under scale? What edge cases am I overlooking? Now the tool isn't replacing thinking, it's pressurizing thinking. It becomes less like a typist and more like a sounding board. Now, recently I came across something fascinating. Donald Knuth, a legendary computer scientist behind the art of computer programming, published a short paper describing an experiment he ran with Claude. He gave Claude a difficult combinatorics problem involving Hamilton cycles in a special graph structure. Now, let's not get into the technical details, but the Claude instantly didn't solve it. Instead, it behaved almost like a research assistant exploring possibilities. It tried one idea, then another, then a brute force exploration, then a pattern analysis, and then a new mathematical formulation. It went through many exploratory attempts before it proposed a promising construction. And that's where Knuth stepped in. He analyzed the idea, generalized it, and produced the formal proof. What's interesting here isn't that AI solved a math problem. The interesting part is the collaboration model. AI explored the space of ideas, the human recognized which direction was meaningful. AI may not produce the proof, but it can help discover which path might be worth proving. So, how do we actually make these tools use in a day to day engineering work? A few patterns that have helped me. The first one is separating thinking from typing. Tools like GitHub Copilot or Claude works best when used before coding begins. Ask it to explore approaches. Ask it to list risks. Ask it to challenge your design. Don't just use it as autocomplete. Next, make your repository speak. AI works dramatically better when your repository contains a clear README explanation, agent instructions explaining about the project and guardrails, architectural notes, examples of preferred patterns. This helps humans and it immediately improves AI alignment as well. Next is use AI to critique itself. One simple habit that makes huge difference is after generating something, ask now critique this solution. Where would it break? Turn AI against its own reviewer. Reduces blind spots dramatically. Try to pitch different models against each other. Next, use AI for system understanding. Tools like Claude are particularly strong at summarizing large code bases, explaining complex flows, identifying hidden coupling. These are tasks where even experienced engineers benefit from a second perspective. The hesitation around AI tools isn't really about productivity. It's about craftsmanship. Experienced engineers don't want to become editors of unclear intent. They want to remain the designers of systems that make sense. Now, AI doesn't remove that responsibility. If anything, it increases it. Because vague thinking now produces output faster and at a larger scale. So maybe the role of engineers is shifting slightly. Less time spent writing lines of code, more time spent expressing decisions clearly. Less implicit knowledge, more explicit intent. And that transition can feel uncomfortable, especially for people who are already good at what they do. But it's also where the real leverage seems to be emerging. Because increasingly, we are not just building systems anymore, we are building systems that help us build systems. Tools, frameworks, automations, and now AI collaborators. So every generation of engineering creates the next layer of leverage. Compilers helped us move beyond machine code. Frameworks helped us beyond boilerplate. Cloud helped us move beyond infrastructure management. And now AI is helping us move beyond some of the mechanical parts of development. Every major shift in engineering has been about one thing: building better tools to build the next generation of systems. But none of these remove the need for good engineers. They simply raise the level at which engineers operate, which means the real skill now is not just writing code. It's learning where these tools help, where they don't, and how to stay firmly in control while still benefiting from the leverage they offer. And like every shift before this, that's something we are all still figuring out. See you in the next episode of Systems and Stories.